Good day, guys. I hope you're all doing so well. Today, it's the functions grade 10 previous question papers. This one I took it from 2019, question number 5. Ne? It reads as follows. Sketched below are the graphs of f at x equal to k over x plus q and g of x is equals to x plus 2. We have two graphs here. The first one of f at x is of hyperbola, and the second one is of straight line or linear function. First bulletin, the equation of the horizontal asymptote of f is y equal to 1. The equation of the horizontal asymptote of graph of f is y equal to 1. And hyperbola has got two asymptotes, vertical and the horizontal. In this case, the horizontal, it is given as 1. Bulletin number 2, the graph of g cuts the x-axis at b. At b, we find the x-intercept. On that line, the x-axis, we find the x-intercept. Last bulletin, graphs of f and g intersect at a and b. A and b are 2 points of intersection between the two graphs. Let's start with 5.1. 5.1.1. Again, it says that you must write down the value of q. Now, guys, the value of q, if you can check from the graph, f at x, we find the value of q as this one. Okay? And whatever we're graphing, hyperbola, there are two asymptotes. Which means, what's about the general equation, hyperbola, f at x is equals to, in this case, another k over x plus p plus q. Now, p and q are asymptotes. P represents the vertical asymptote, the vertical asymptote, the vertical asymptote. In this case, the vertical asymptote is 0. In this case, then the horizontal asymptote is q. The horizontal asymptote is 1. In this case, the value of q in this case is 1. This is our q is our horizontal, p is our vertical. Horizontal, vertical. This graph will never touch this line. These two graphs will never touch this line, this dotted line. And again, these two graphs will never touch the y-axis line. Because of what? Because of the asymptote that is vertical is equals to 0, which is the value of p is equals to 0. So the value of q is equals to 1. And the value of p, if there's k over x, if there's nothing here, therefore it is x plus 0. That 0 is the value of p. Graph will never touch the y-axis line. That's the basic logic behind that thing. 5.1.2, it says that you must write down the domain of f. Domain of f. Now, domain are all x values that are real. Domain of f are all x values that are real. Now, domain hyperbola is very different. Now, where do you find the domain? You must come where you see x on the graph. Where do we see x is our denominator here, which is x plus 0. And guys, we said if there's nothing, is x plus 0 there. Yes. Now, that's where we find the domain. X plus 0. This is where you find the domain. That's it. And this x plus 0 should not be equal to 0 all the time. If it was x plus 2, we are going to say x plus 2 should not be equal to 0. You should just say equal to, and you just say slash. It means that this expression should not be equal to 0. All the time you do that to find the domain, only for the domain. And if by range hyperbola, you must say y should not be equal to 1. This q1. Which means the domain works together with our vertical asymptote, and the range works together with our horizontal asymptote. Therefore, you solve for x. Transpose 0 to to the left, and to the right actually. So when you transpose 0 to the right, it's gonna be x is not equal to 0. This is your domain. It's very simple. This is your domain, guys. That's how you find the domain of a graph. Are we clear? Yes. How about range for this? This is the domain. Domain. This is only for hyperbola, not other graphs. For hyperbola, then for range. Range, you don't need to calculate anything. You just say y. Your range is all y values that are real. All y values that are real. That's our domain. That's our range. All y values that are real. Domain. All x values that are real. Y should not be equal to your asymptotic horizontal, which is 1. Then you are done. That's how you find the domain and the range of a hyperbola function. Simple, guys. Yes, very simple. Let's go to 5.2. 5.2, it says that determine 5.2.1 determine the equation of the line of symmetry for f that has a negative gradient. Negative gradient, very important. Negative gradient. So the equation of a line of symmetry of graphia hyperbola that has a negative gradient. Very important. This is the equation of negative gradient if you want to find the equation of a line of symmetry of f that has a negative gradient. Okay, y equal to negative x plus p plus q. Level. This is the equation of the line of symmetry of f that has a negative gradient. You just put the negative in front of this bracket by x plus p and plus q. How about a positive gradient? You just remove this negative sign here and you simplify. How about a negative gradient? You put this negative sign here. It's very simple. This is the equation. Line of symmetry for hyperbola graph only. They will ask you this type of question. Hyperbola, not any other graph. Hurry, substitute negative x. What is the value of p? Is 0, plus 0. What is the value of q? Plus 1. Then you just solve for y. Simple. You just simplify. And you want to say about this negative 1 is going to multiply each and every term in our bracket. So negative 1 times x is negative x. Then negative 1 times 0 is 0. Negative 4, any number times 0 is 0. Then 0 is invisible. Then you're left with plus 1 here. This is the equation of a line of symmetry of a graph that has a negative gradient. If by a positive gradient, you're just gonna remove this negative sign here and simplify. Simple, guys. Very simple. Simple. Very simple. 5.2.2. 5.2.2. It says must determine the equation of f. F at x, and the equation f at x is equals to k over x. There's no need for you to write the 0. I just wrote the 0 to show you how to find the vertical asymptote. So that's the basic logic behind the vertical asymptote part. Now, you must find the equation of f at x. How do you find the equation of f at x, guys? To find the equation of f at x, you will need... Now, how do you find the equation of f at x? Graph f at x. About like k. In this case, about like k. About like k. That's the basic logic behind finding the equation of f at x. About like k. Now, we need to check the graph ukuthi which point that lies on the graph of f can we use. You just check the graph of f. Do we have known coordinates? If we have got coordinates that are known, use those coordinates to find the equation of f. How to check something? We check this graph here. Do you have the coordinates of a? No. So you leave it out. You leave it like that. Do you have the coordinates of b? No, we don't have coordinates of b fully. How to check? The coordinates of a are x and y are unknown. You just leave them like that. Then the coordinates of b, very important. The coordinates of b, I get this b lies on our x-axis. and B rona they told you ukuthi y x-intercept and x-intercept you do what? You let y be 0. We don't know x, but you know ukuthi y rona is 0. Now B again, it touches the graph via straight line, which I can use. When graph via straight line is known, I know the graph equation of the straight line graph. I can use the equation of the straight line graph to find the coordinates of B. Why? Because B lies also on the graph via hyperbola, and I need to find any point that lies on the graph of hyperbola. Hence, I'm going to use the coordinates of B, because B lies on hyperbola and also on a straight line. So you can find the coordinates of B through the use of the equation of straight line, and simultaneously I'm going to find the equation of F. Yes, let me just find the coordinates of B through the use of this equation as G at X. So I'm going to let y be 0. Since on the graph here G at X, I'm going to let y be 0 and find X. So it was 0 is equals to x plus p plus 2, then x yaga. Therefore, I'm going to transpose this 2 to the left, and it over x is equals to negative 2. So coordinates of B are negative 2 and 0. Negative 2 and 0. Therefore, now I'm going to use this coordinates of B. Remember, this is part of the solution, by the way. I'm going to use this coordinates of B and plug them here to find k. Where I see x, I put in negative 2. Where I see y, I put in 0. That's how you're going to find k. So y I want to get 0, I put 0 on my left. K over x I want to get negative 2 plus 1. Then solve for k. How do we solve for k? Transpose each and every term that does not have k on the other side. Which one? One that doesn't have a k, you take it to the left. Over 0 minus 1, negative 1 again. Then k over negative 2. Then you have to solve for k in this case. If you have something like this, an equation like this one, you just need to cross multiply. Come to k times 1 k. Then negative 1 times negative 2 to positive 2. Then so you have found your k. Therefore, your equation of f at x is equals to 2, which is the value of k, and get 2 over x plus 1. Then you are done with finding the equation of f at x. That's how you find the equation. Once you've got 2 and you just write 2 yeah, that's how we find the value of k, guys. I hope we are clear. I hope we are all clear. Yes, guys. Now the last question. The last question is 5.1.3. It says that determine the coordinates of A, a point of intersection of F and G. Coordinates of A, point of intersection. Very important. Coordinates of point, rather coordinates are A. I hear we've got coordinates of B already, rather coordinates are A right now. How do you find the coordinates of A? And they told me what coordinates of A, which means A is a point of intersection between the two graphs. If the point intersect between two graphs, therefore for you to find the coordinates of that point, you must equate the two graphs. Which means I must equate the graph of f at x with q at x. And here's our f at x. It's the same as y. Let me just write it like this. Y is equals to 2 over x plus 1. The other one here, g at x is equals to y equals to x plus 2. Simultaneous equation. Equation number 1, equation number 2. Remember, in simultaneous equation, you must one of your variables must be the subject of the formula. Come on, so in this case, y is our subject of the formula. Y again is our subject of the formula. Y on both sides is our subject of the formula. Which means if y indeed the signs are the same, and everything is the same on my left, y they're the same. There's no 2 or 3 next to our y. It's just y only, y. If they're the same like this, therefore you just equate this part here, right? It's about 2 over x plus 1 is equals to x plus 2. So you just equate equation number 1, equation number 2. Just equate them if this is the case. then solve for x. You can see that there are functions here. How do you deal with function? Over 1, over 1, over 1. If you have a function, you must find the lowest common denominator. What is our lowest common denominator? You multiply your denominators. X, 1, 1, 1. You multiply them out. X times 1, x times 1, x times 1, x. Our LCD is x in this case. Therefore, you're going to multiply each and every term by x. Hurry. 2 over x times x. This x will cancel this x, will have to 2. X times 1 plus x. X times x, x squared. 2 times x plus 2x. Okay, guys. Therefore, I have a squared here. That means I might have a quadratic equation of some sort. If you know x squared, I'm going to transpose, I'm going to add like terms. That's one. So I want to be left with 0 on one side only. I put 0 on one side and add like terms on the other side, and all together. 2x, I get this x, I'm going to take it to the right. It's about 2x times x. 2x minus x, and not 2x times x. 2x minus x, and get over plus x. Then this 2 is going to come to the right. It's over minus 2. Whatever, guys. After that, this is a quadratic trinomial. Until you know what to do with the quadratic trinomial, you can open 2 brackets. You can simplify it by opening 2 brackets. You open 2 brackets. Factors of x squared are x and x. You can do long ways by saying, you multiply this one with negative 2 and find factors of 2 and stuff like that. It's going to take a lot of time. Now, what are factors of 2? You're going to multiply. The simplest method here. Let me just do the method that you've been doing since from algebra. And for me to find the factors, I'm gonna, the first step, you multiply this one by our constant, which is 2. 1 multiplied by 2. I get this one here on x squared times 2. You 2, guys. Then you're gonna find, second step, you must find the factors of 2. What are factors of 2? Factors of 2 are 1 and 2. Now, between those two factors, between the factors that 2, which 2 terms can I use? Of which, when I add them, they must give me the middle term. When I subtract them, when I multiply them, they must give me the last term. We've got 2 factors that 2, 1 and 2. Which means 2 and 1 are indeed, because the already add, already minus, they refer the middle term, which is positive 1. So I get about 2 minus 1, 1. Indeed, 2 and 1 are factors because of what? When I minus them, they give me the middle term. When I multiply them, they give me the last term, which is negative 2. So 2 and 1 are indeed factors. Then the sign, they're not going to be the same. We'll check the center. The bigger number takes the sign of the middle term. Which one between 2 and 1 is big? Is 2. I'm going to 2 don't got the middle sign now, which is positive. Then you say, for you to find the sign, I'm going to talk positive divided by negative. Whatever, guys. Therefore, x and give what's about x plus 2 equal to 0 or x minus 1 equal to 0. Those are 2 products. So x is going to be equal to minus 2 again, or x is going to be equal to positive 1. They're just going to change the sign, these 2 again, for to negative to positive. Now the coordinates of a, you must just write them. Coordinates of a, you're not done again. You're not done. I just have some money x here. You just found x. We need to find y. Okay. So this x here, when x here is on this part here, graph, it means x here should be positive because of what? It's on top. Okay. It's on our x-axis, on the right side of the x-axis. This coordinates the x come, they are positive. Okay. Our x should not be equal to negative 2. For coordinate a fair. Means coordinate a first coordinate x coordinate a to 1. How do you mean that, okay, guys? Then you got the coordinate y. How do you find y? I'm gonna use this x coordinate that I've just found here on any of the 2 equations to find coordinate y. Okay? So I can just put this one where I see x and find y on the equation number 2, y equal to 1 plus 2 is 3. Therefore, coordinates y is 3. Therefore, coordinates are a, 1 and 3. X cannot be equal to negative 2 because of what? Coordinates are this part, yeah, x exists. They are positive. This negative 2, it is the x coordinate of what? Of b. We just found out that b is negative 2, and hence we don't need the negative 2 sign. I hope we are clear, guys. I hope we are all clear. Let's go to question 6. So guys, question 6, it says that the graphs defined as g at x, so question 6, the graphs defined g at x is equals to ax squared plus q, and f at x is defined as k to power x minus 4. Okay? Both pass through, which means these two graphs, they pass through both of them. They pass through coordinates of negative 2 and 0 on the x-axis, and by the y-intercept of g is 0 and minus 5. I hope you're clear on that one. Then 6.1, it says that write down 6.1.1, write down the equation of the asymptote of f. The equation of the asymptote of f. Now, let's analyze the graph. The first graph is of g at x, and there's got a squared here. Okay. If a graph has got a squared of some sort, that graph is a parabola graph. Ne? If you've got a squared here, some sort of a squared, when dealing with functions, you must just think, oh, that graph is a parabola in most cases. Ne? Then the graph of f at x, if it has got a base with an exponent, in most cases, that's no good. That graph is of exponential graph. It's of exponential graph. An exponential graph has got an asymptote. Only one asymptote, and asymptote, the exponential graph is determined by this value. Yeah? This one, this last value. Yeah? Always that value is always the last one. That's our asymptote. That's the only asymptote that this graph has got, which is negative 4 in this case. Now the question says that write down the equation of the asymptote of f. What is the asymptote of f? Asymptote of f is the last value. Thank you. What is the asymptote of f? Is this negative 4. Therefore, just write y is equal to negative 4. This is our asymptote of graph of exponential. Thank you, guys. I hope you are clear on that one. 6.1.2, you must write down the value of q. Write down the value of q. What is the value of q in this case? The value of q is our graph here, g at x. Parabola, as we have mentioned, this is a graph of parabola, and the value of q, when you define it, the value of q is the y coordinate of the y-intercept. Now they told you the y-intercept of g is 0 and negative 5. These are coordinates of y-intercept of graph of g. Now we are saying to you q represent the y-coordinate of the y-intercept. And what is our y-intercept in this case? Is 0. These are coordinates of y-intercept, the graph of g is 0 and negative 5. Now you just take the y-coordinate of that y-intercept. What is the y-coordinate between 0 and negative 5? Negative 5. Therefore, q is equals to negative 5. Well, simple, guys. Very simple. Now, 6.1.3. I hope you are clear. You must write down the coordinates of the x-intercept of g. Of the other. Which means the same you must write down the coordinates of the other x-intercept of g. The other x-intercept of g. I think this one is very important. I give you guys graph ya parabola. If you can draw the graph of parabola, let me just draw a rough sketch of graph of parabola. And just rest. If you can draw, in most cases, guys, if you draw the graph of parabola, yeah, in this case, if you've got just the coordinates on this side, let me just say -2 and 0. Then if they ask you what other coordinates on the side, they're gonna be the same, but this is gonna change the sign to about 2 and 0. They share, they're the same. Which means this actually they are cut in the middle. We call it the axis of symmetry. So if they are cut in the middle, it means the x coordinates or the x-intercept are gonna be the same in terms of the length from the origin. Length from the origin is 2 units to the left, 2 units to the right. They're the same. They just change the sign in G. So the coordinates of the x-intercept in this case, I give this graph, this graph as G at x pass through the coordinates are -2 and 0. And you choose these two graphs, they pass through these coordinates are -2 and 0. And this is the x-intercept. X-intercept, by the way, of the graph G at x. And I'm told you, okay, since right now we're talking about this graph being cut into 2 equal parts, it means the length from the origin is going to be the same on both sides. Therefore, if it's -2 and 0 on this side, the coordinates on this side are going to be 2 and 0 on the x-axis line, not y-axis line. So this is the coordinates of x-intercept. Therefore, the other coordinates, write down the coordinates of the other x-intercept of G. What is the other x-intercept of G? It's going to be 2 and 0. Since I get -2 and 0, therefore going to be 2 and 0 when you change that one. I hope we are clear on that one. Let's go to 6.2. Hey guys, we're explaining here. 6.2. Let me just move. Let me just write them properly, guys. Here. Here we told you the value of Q. The value of Q. The value of Q is -5. So the value of Q is -5 here. And we just wrote it down. We're just updating the information on the diagram. 6.2. It says that determine the equation of 6.2.1, the equation of G. The equation of G, G at x is equals to a x squared minus 5. So what the equation of G? In this case, about a and the equation of y equal to ax squared minus a in this case. How do you find a? For you to find the equation of any graph, you need to find the coordinates that lies on the very same graph you are trying to find the equation of. Which coordinates lies on the graph here? On this graph here, parabola. I give about they told you these two graphs, they pass through this coordinate. The coordinates that -2 and 0, they indeed also touch the graph here, parabola. I'm going to use these coordinates to find a yak. Which means where I see x, I put in -2. Where I see y, I put in 0 to find a. 0 equal to a. Where I see x, I put in -2 squared minus 5. And guys, then what a and whatever that does not have a, you take it to the other side. 5 and a to the left. 0 plus 5 is 5 equal to a. -2 squared to 4 times 4. A, I divide both sides by 4. I don't want to multiply more. Therefore, I divide both sides by 4. Therefore, a is equals to 5 over 4. I hope we are all clear, guys. A is 5 over 4. That's how you find the equation of any graph. You must just find the coordinates that already lie on that graph, then you'll be fine. 6.2.2, the equation of f. Here f at x is equals to k to power x. We found, thank you for that, k in this case, yes. Again, y is this, again f is the same as y. K to power x minus 4. Now give it k. How do you find k? Again, you use any coordinate that lies on the graph yanto ya g on the graph ya f at x. Okay. Now, which coordinate lies on the graph of f at x? Which coordinate lies on the graph of f at x? They told you go to these coordinates. They both, which means this graph, these two graphs, both pass through these coordinates at -2 and 0. Therefore, I'm going to use -2 and 0 in this case again to find k. Where is x I put in -2, where is y I put in 0? 0 is equals to k to power -2 minus 4. Again. Then I'm going to transpose, like, keep it like k. Anything that doesn't have k, take it to the other side. -4, about 0 plus 4, give 4. Then to k to power -2. Now, to simplify such problems, you need to know how to use reciprocals. Reciprocals means the change, which means phetolelo, the exchange between numerator and denominator. -2 over 1. To remove this negative, you only do it if and only if not exponent then you just say -2 over 1 multiplied by what is the reciprocal of -2 over 1? This one is going to come on top, and this -2 is going to come at the bottom. Then this reciprocal here, which is 1 over -2, is going to multiply and give us about 4. This 4 gives us another 1 to power 1. This one is going to multiply by your reciprocal, which is 1 over -2. Guys. Then this -2 will divide this -2, this one will divide this one, then we have with k. Here 1 is equals to the reciprocal of 4 to power -1 over 2. Our answer is going to be 1 over 2, which means the value of k is equals to 1 over 2. That's the value of k, 1 over 2, guys. That's how you simplify it properly. I hope you're clear on that one. Let's go to 6.3. It says that calculate the y-intercept of f. Y-intercept, you do what? You let x be equal to 0. I'm going y-intercept of f. F at x equal to 1 over 2x, 1 over 2 to power x minus 4. Okay, I let x be equal to 0. Okay? So I'm going to have 1 over 2 to power 0 minus 4. Yeah? Then when I want to keep equal to 2, I give out any number to power 0, get 1. Any number to power 0, get 1. Now it's about 1 minus 4. It's about -3. You can put that on a calculator. It's going to give you -3. Therefore, coordinates of our y-intercept are 0 and -3. Are we clear? Are we clear, guys? Yes. I hope we are clear. The last question for this paper, 6.4. It says that you must sketch the graph of G and F showing all the intercept, asymptotes, and also I'm going to draw the graph of these two functions. Let me just draw them very fast. I'm going to draw the graph of these two functions. I'm going to draw them properly here. Now, I want to say this graph where exponential has got the asymptote, which is -4. Therefore, I'm going to draw, I get the horizontal asymptote fairly one. I'm going to draw dotted line monana. And you guys. And we just found the coordinates of y-intercept, which is coordinates of y-intercept, which are 0 and -3. Which means 0 and -3, it can be here. And we can find the coordinates of x-intercept for f at x. X-intercept, you let y be equal to 0. Guys. Then over 0 is equals to 1 over 2 to power x minus 4. Then I'll transpose this 4 to the left. I get over 4 equal to, and you 0 plus 4, it over 4, 1 over 2 to the power x. Couple alternatively, the simplest way is to draw the box and box of x and y. The simplest way is to draw the box of x and y when you want to draw the graph of these functions. And you give yourself x values from -2, -1, 0, 0, 1, and 2. So for f at x, and for f at x graph here, exponential, you put -2 acx, it's over 1 over 2, to power -2 minus 4. The answer is going to be 0 and -2. Coordinates for x over 0 and -2. Our x is going to be -2 and 0. You over 0 more. So it's going to stay here. Then we put in -1 where you see x again. It's going to give us -2 again. -2. Comes by -1 and -2 can be here. Then when you put in 0, it's going to give you -3. Just calculated it. And this is our y-intercept. When I put in 1 again, it gives me -7 over 3. It's 3,5 and it means then obviously it won't touch the asymptote. It will graph face off. Now, then that's how a graph will look like. This is exponential graph. I hope you are clear, guys. This is the simplest way to draw the graph. Use this box to guide you in terms of the shape of the graph and everything. Let's go to the graph here, g at x. The simplest way here, I'm going to put in, where I see x, I put in -2 to find y. When I put in -2, I see x, it gives me 0. When I put in -1, where I see x, it gives me -3,75. When I put in 0 there, it gives me -5. When I put in 1 there, it gives me -3,75. When I put in 2 there, it gives me it gives me 0 also. So now I'm gonna plot the graph here on the same set of axes. So -2 and 0 is found here. Then -1 and 3,75, -1 and 3,75 can be found here. Then 0 and -5 can be found at the bottom of our asymptote of exponential graph. Then 1 and -2,5 is going to be found here. And 2 and 0 it must be found on my x-axis. Yeah, then I'm just going to join the points. Okay. It's very simple to draw the graph with the use of this box, because it's going to help you, it's going to guide you with how will your graph be shaped like. So these are 2 graphs for this question 6. That's how you draw them. Thank you very much, guys.